algebra of limits. So when we get a question on limits, we need to know the basic operations on them. So there are like addition, subtraction, multiplication, division. We can do the same thing on limits. So I'll give you an example. Suppose we have two functions where we give limit x tends to a for f of x plus g of x. Alright, if this is the case, we can give limit separately to them. Limit x tends to a f of x plus limit x tends to a g of x. So what did we do here? We gave the limit separately to these two. So we understand that limit is distributive and we can distribute it to the individual terms when plus or minus is there. So we can write plus or minus. And for the next case, limit x tends to a c of f of x when c is a constant. So c is a constant, it's not part of this f of x. We can actually take it outside of the limit, c times limit x tends to a of f of x. This will help simplify problems later. Like for example, if we have limit x tends to 2 x square minus 2x for x square minus 2x, then we can take 2 outside and write 2 times limit x tends to 2x square minus x. We just took 2 outside from the whole thing and made it a little simpler. So third result, if we have instead of a constant we have another function f of x times g of x, pointwise multiplication of two functions, then it's a little similar to addition. We can just give this limit plainly to the both of them separately. Limit x tends to a f of x times limit x tends to a g of x. We can give the limit separately for plus or minus or multiplication, and for division, as you can see, limit x tends to a f of x divided by g of x. If this is the case, we can give limit x tends to a f of x divided by limit x tends to a g of x, provided that this limit when given to g of x does not end up in equal to 0. If it ends up at equal to 0, we cannot apply this, since that would mean a undefined result. So we can't have limit x tends to a g of x equal to 0. But if that's not the case, then we can apply it directly. So these are the 4 main results of algebra, and now we can learn how to actually solve these problems using 4 techniques. First one is direct substitution. So you're pretty familiar with this one. I've did it in the previous classes. Direct substitution means just applying the limit. So suppose we have a question, limit x tends to 3 2x plus 1. In this question you have pretty much not anything to do. We just have to directly apply the limit. So what do? You just apply wherever you see x, you give the value of 3. So 3 into 3 plus 1, which is equal to 7. So that was direct substitution. But in some cases, like for example, limit x tends to 2 x square minus 4 divided by x minus 2. In this case, if we give direct substitution, we get 2 square minus 4 divided by 2 minus 2. What would this be equal to? 4 minus 4, 0, divided by 2 minus 2, 0. We get this in the form 2 0 by 0 form. Now this is actually a case. We cannot have a limit which is evaluating to 0 by 0. It can either be 0 or it can be undefined. This is 0 by 0. So what does that mean? We did something wrong. We have to find another method. That another method is called factoring method. So since direct substitution did not help, it just gave us 0 by 0. Let's do some factorization on this function. Limit x tends to 2, x square minus 4 by x minus 2. So what type of factoring can we do? We see that this is x square minus 4. What is 4? 4 is 2 square. So we see this is x square minus 2 square, or a square minus b square. What is a square minus b square? A square minus b square is equal to a minus b into a plus b. So we can rewrite in the form limit x tends to 2, x minus 2 times x plus 2, right? A minus b into a plus b, and the denominator. Now we can see these two perfectly cancel out each other. So we can cancel these two out and end up with the result limit x tends to 2, x plus 2. Now we see no other further factoring can be possible. We just apply the direct substitution. So wherever you see x, you write 2. So 2 plus 2 is equal to 4. Here you did not get a 0 by 0 form. You got an answer, proper answer. So with this method, factoring method, you can actually get the answer. So you have to always check whether there's something to factor out, and you have to check whether it's 0 by 0 by directly substitution first. So first of all, you have to do direct substitution and see if it ends up with 0 by 0. Then do the following method. You can either do factoring method, or you can do the next method, which is the rationalization, or the next one using algebraic identities. Rationalization, which is the third technique. Suppose we have a limit x tends to 0 root of x plus 1 minus 1 divided by x. Okay, so for this example, we just do direct substitution first and check root 1 plus 1 minus 1 divided by 1. No, 0. This was 0. X tends to 0. So we have to write 0. So this would equal to root 1. 1 minus 1 is 0 divided by 0. So we got 0 by 0 form. Now what do we do? We see there's nothing to factorize really in this. So what can we do when we see root? We can actually rationalize it, right? Rationalize means multiplying the conjugate of this with denominator and numerator. So I'll write it down what I mean. Root of x tends to 0. Root of x plus 1 minus 1 divided by x. Now multiplying the conjugate means just remove this minus and put a plus. So multiply with the plus version of this, root of x plus 1 divided by root x plus 1 plus 1 on both numerator and denominator. We see this is a minus b into a plus b, a minus b into a plus b. So we can write limit x tends to 0. If we open that, we get x plus 1, root x plus 1 whole square. So the root and square get cancelled out. So x plus 1 minus 1 square, which is 1, divided by x into root x plus 1 plus 1, right? Cancelling this, 1 minus 1 is 0. So x plus 0 is x itself. So limit x tends to 0. X plus 0 is x into root x plus 1 plus 1. We can cancel x and x. We get limit x tends to 0, 1 divided by root x plus 1 plus 1. Now we do direct substitution. We can write 1 divided by root of 0 plus 1 plus 1, which is equal to 1 divided by root 1 is 1, 1 plus 1, which is equal to 1 by 2 as the final answer. So we see, we do direct substitution, see the answer is 0 by 0, then we get on to other methods like factorization. But in this case, we had to use rationalization because there was a root. Now the next method, using algebraic identities. So we know what algebraic identities are. It's something like a plus b whole square or a minus b into a plus b. All the stuff you have learned in previous classes. So suppose we have a question, limit x tends to 1, x cube minus 1 by x minus 1. So in this question, if we do direct substitution, we can write 1 minus 1 divided by 1 minus 1. 1 cube minus 1, which is equal to 1. So this is 0 by 0 form itself. So in this case, what can you do? We can't really factorize it, and we can't rationalize it because there's no root. So what can we do? We can identify the problem. We see that this is x cube, and if we want, we can write 1 as 1 cube because there's no difference. So this is in the form a cube minus b cube. What is a cube minus b cube? A cube minus b cube is a minus b into a square plus ab plus b square according to the identity. So we can rewrite it as limit x tends to 1, x tends 1 into x square plus x plus 1, right? A square plus ab plus 1 into a minus b divided by x minus 1. You can see these two perfectly cancel out each other, and during direct substitution 1 square plus 1 plus 1, which is equal to 3. So our answer would be 3. So we have to know all the algebraic identities if we have to apply this with ease.